Thank you again for making the trip down here. Hopefully we'll make that hike worthwhile for you. So my name is Rich Rue. I'll be joined here today with David Crawford. We're going to talk about the Utility Network API for ArcGIS Pro. Just to talk a little bit about what our agenda today is going to be, just a quick note on how to get started. Then the bulk of the talk will be a survey of the Utility Network APIs. We'll also talk about what's new, and then a quick section on the road ahead, and finally just a couple of pointers on how to learn more. And we're going to have some code demos sprinkled in with the slides so you don't get PowerPointed to death. All right, getting started. If you remember one thing from this talk, that is the URL for the ArcGIS Pro SDK homepage. You probably don't want to remember the URL, just type in ArcGIS Pro SDK into your favorite search engine, and that will lead you there, and that will give you all the information you need to start programming. So the Pro SDK, it's a .NET managed SDK that provides access to the utility network. So this is an object-oriented SDK, uses modern C# practices and patterns, basically fits in with the rest of the Pro SDK. So one thing we're going to talk a lot about the utility network today. Who here has a background on the general utility network concepts? Hopefully that is just about everyone. Great. There's been a couple talks throughout the week. If you missed them, I think they'll be on YouTube later. Architecturally speaking, the Utility Network SDK is DML-only, data manipulation language, right? So schema creation and modification is handled through geoprocessing. So you can do that by calling out to the geoprocessing API. There's a little code snippet, how to import rules. Or you can, if you're running a standalone program, shell out to Python and actually do it that way. So things like creating tables and so forth have to take place through geoprocessing. I'm not going to get into threading too much. If you're coming from an ArcObjects-Com background, this is probably the single biggest hurdle that you have to overcome. There's a link there on the presentation to give you more information, but essentially what you need to do is almost every routine and class we're going to talk about today should be called from what's called the main sim thread, or the MCT. And the way to do that is you create this thing called queued task run, and inside the predicate you put all of your utility network code. So essentially what you will do in your pattern is you run your utility network code, really all geodatabase code, inside queued task run, which puts it on a special COM worker thread, and then when you come back, you use the regular UI thread to display results. So almost everything that we talk about today is in the ArcGIS core.core.data.utility network namespace. There are a couple of other namespaces underneath that for specific functions such as tracing and network diagrams. Now, one thing that's new from last year is we've felt the need to add some C# extension methods. So if you're not familiar with an extension method, think of the architecture. At the bottom layer, you have the utility network and other geodatabase routines. And it's a layered architecture, so the stuff on top is for interacting with the Pro desktop application. So what we found is we need to call the Pro desktop application from our low level down here. And that, of course, does not work so well. You can't really call it a layered architecture if you're calling both directions. So what we did is we created some extension methods in the desktop namespace. And if you've never used a C# extension method before, how to basically do it is you add a reference to arcgis.desktop.extensions into your solution, and then you add a using clause at the top, and then what that will do is it appears to add methods to some of the classes in the API. So you can call it as if it is a class method, but it's actually an extension method. We'll talk some of the examples as we go through. Before we get into the rest of the C# things, just a reminder, there are other ways to program against the utility network. Geoprocessing and Python scripts are often a good solution if you don't need to use the C# SDK. And you could always directly code against the REST APIs. Remember, everything in the utility network, it's a completely web services-based system, so all the functionality is there by calling out to REST. Okay. This diagram is kind of my organizational diagram, just breaking the utility network into some digestible chunks. It is not a layered architecture. This sometimes implies this is layered architecture, not really. This is just kind of a grouping of organization. So we're going to step through kind of each of these things in turn. So we'll start with the utility network class. This is the root object that provides access to the API. And you get this thing from a geodatabase. So it is a data set on the geodatabase, so that if you know its name, you call geodatabase.openDataset, you pass in the name, and you'll get back this utility network object. And again, this is kind of the central hub. If you have a feature class or a table, you can call getControllerDataset on it, and that will also give you the utility network. And the other thing you can do is get it from the utility network layer itself. I think with that, we'll actually show you what that looks like in the real world.
All right. Can you hear me at the back? Maybe not. Stunned silence generally means you can't hear me. There you go. I got one thumbs up. So, as Rich talked about, so the first thing that we need to know in our SDK is always how do we get to the utility network. Obviously, if I'm working within ArcGIS Pro, I have a layer for my network over here. It seems like the most logical point, but there's actually 3 different ways you can access or open the utility network. So I wrote a little add-in here that we're going to click through these add-ins as we go through our little session here. But the first one that we go is accessing the network itself. So we jump to the code behind when we click the button. And the first way we can open it, as Richard described, is directly off the geodatabase itself. So if I jump inside this method, you can see that as we go, so again, everything's inside this queue_task.run. Because it needs to be running on the main sim thread. Pretty much anything you do with the geodatabase itself needs to run on the main sim thread. That is not unique to the utility network components.
Can you make a text bigger?
Yes. I can zoom in more. Is that better? Okay. Yes, yell if you can't see or hear, or just in general want to yell at me. It's more than welcome to.
He's used to it.
Yes. So the first place we start is we have to open the geodatabase. So anyone who is familiar with ArcObjects programming, this is very similar to the way you used to open a workspace in ArcObjects, except now we have our geodatabase object. And within that, I can actually pass in the URL directly to my feature server. That is where what is considered the geodatabase when you publish services is the server itself. From there, I can get all of my geodatabase behavior. So I have this little snippet in here that just shows that we could do versioning if we wanted to. Again, this falls into the same general geodatabase behaviors. If I was to get a version, create it, and then open it, I would get back the geodatabase object, which I can then turn around and call openDataset on, and I can call open and look at all the other things in it, get tables off of it, and all of those will be coming from that version of the database, or from that branch. It won't be coming from default. For the purpose of this demo, we just have to open it so we can go off default, so I don't need to go and create any versions. But as we see off the geodatabase, I can actually go, because it's a feature server or feature service, the layer names or the names of the classes that get stored in the server are not just the human readable electric utility network or whatever you've called it. It actually gets prefaced with a number, an L and then the number. It's the layer and the layer ID in the server. So the way that I've gotten around opening these things is I just ask for all the utility network definitions that are in my service. By iterating through them, I can then find the one that I'm specifically interested in using the name property or this getName method. In my particular one, I only have one utility network, so it makes it quite easy. I just find the definition and call open on it. Right now you can't see it, but you'll see in the return back up here. Now that I've actually opened it, so I just call that open dataset. I give it the type right here. So this open dataset is generic. If I was opening a feature class, I would just pass feature class in here and the name of the feature class, returning back that type. I get it back, and then again in a queue task, because I'm going to be accessing things in the utility network or in the geodatabase, and all I really want to get is the name. So I can show you. Now that is going to be really difficult for anyone who couldn't read it. The other thing so I'll see if I can make it as big as I can, but it's actually prefaced with the L17 and then the name of my utility network. That's why I use that definition object to go get it. That way I never have to guess if the name that I'm typing in is correct. If it fails to open, is it because it doesn't actually exist, or I just typed it in wrong, I forgot the L numbers, things like that. So that's the way you would open these utility networks if you're just at the geodatabase itself. You're writing a headless app, you're writing some standalone executable core host application. But there is other ways to do it if you're actually building within the add-in. So the two other ways we can do it is from layers, or in my case, the subtype layers that I have in my map. I can iterate through all my layers. Whoops, sorry, I did that way too fast. Let me just jump in there, because that's easier. I can iterate through all my layers, and when I find a layer that is a feature layer, I can ask it for the table that underlies that layer. From that table, I can ask the question, is a controller dataset supported? So that's essentially the Boolean that you can check for whether or not you should try to open something else. Generally, if you try to just call open on it or get the controller and there isn't one, it will throw an exception or optionally return the null. But checking these Booleans beforehand is the safest way to make sure that the information you're going to get back is what you think it is. I can then get all the controller data sets from my table, loop through them, find the specific controller data set that I just type check that it's a utility network, and then I can just cast the controller directly to that network. And now I have that same utility network object directly from one of the layers in my map. So it's the same name of the object, same type, utility network. And the last way we can do it is from the utility network layer itself. This is obviously the least amount of code you would have to write, and it probably makes the most sense in most cases. You can just iterate through all the layers, find the one that is the utility network layer, and from the utility network layer itself, there is a get utility network method that allows you to just grab that utility network, open it up, and return it back out to yourself. So again, I just print the name so that you guys know that I'm not lying to you when I say that I actually got it open. So we get it open. And those are the three sort of basic ways that you would open the utility network so that you can interact with it.
Thanks, Dave. So moving on, we have an addition. The next object in our series is we have a set of definition and schema objects. So we're not going to go through each of these. It would take too long. It would take the whole hour. You'd learn a lot about utility networks. However, these things here more or less match what you see when you right-click on the utility network in Pro and you say properties, network properties, and all that information there is more or less what's in here. Worth pointing out though, this is all read-only access to schema information. Remember, you need GP to change anything. And the other thing worth pointing out is these are all value objects that are cached. When you make your first connection to the feature service, all this definition information comes back. So it's worth knowing that you can hit any of these things and it's not going to make another call to the service. Element. Element is essentially a row inside the utility network plus either a terminal or a percent along an edge if applicable. So it's a little bit more than a feature, right? So you can use these to create and delete associations. So if you want to create a structural association between a pole and a transformer, you just have one element for the pole, one element for the transformer, and you pass that into the routine. Likewise, you use elements to specify starting points or barriers. So if you wanted to put a barrier midway down an edge, you'd create a element from that edge and fill in the percent along edge value appropriately. And finally, elements are returned as results from traces. So if your trace stops at a transformer, you may have in your trace results the upstream terminal of a transformer. These things are all created using create element factory methods on the utility network. So they are also lightweight objects. So network topology, the routines around network topology. For those who aren't familiar with the idea behind the utility network topology, it is essentially an index that contains all the containment, connectivity, and attachment information used by the utility network. It's created from a couple of things. It's created by features that are geometrically coincident, and in that respect, it's like the old geometric network, but it also uses the associations that you've added to your system, along with the rules engine. So two features that are not allowed to connect, we don't connect them. So to update topology, after you've made an edit, you call this routine called validate network topology in edit operation. And this is one of those extension methods I talked about at the beginning. So not only is this going to update the network topology, but equally importantly, if you're running this in an add-in, it's going to refresh the portion of the screen that had your dirty areas, and it's going to create an entry on the undo redo stack in Pro. Worth pointing out, the utility network does not provide access to fine-grained topology. In the geometric network, you could step between edge junction, and work your way down. When each of those jumps is a call to a feature service, you can imagine that performance would not be so good. So the way we handle operations with topology is with our tracing framework, which we'll talk about in a few minutes. Associations, the API contains a set of routines to query and edit associations between utility network rows. So hopefully everyone's familiar that there's three kinds of associations. There's a connectivity association, which allows you to specify that two junctions are attached to each other without drawing an edge. A containment association, so a fuse or a switch inside of a switch cabinet. And a structural attachment, so a transformer bank attached to a pole. We have routines to query associations from a given element, and we have routines to edit or create associations as well. Subnetworks, another very important part of the utility network. The subnetworks area, we have routines to query and edit utility network subnetworks. So what is a subnetwork? Well, basically what it does is it allows you to keep track of connected features. So in the electric world, this is an electric circuit. In the gas world, this is something like a pressure zone or a cathodic protection system. So the Subnetwork Manager is the class that allows us to get to all of these routines. So you actually get the Subnetwork Manager from the utility network central class. A couple things you can do here. You can call get subnetworks that will query a list of all subnetworks within a given tier. You can also add controllers. So this is what we used to call a circuit source. You can add a controller or remove a controller with these two extension methods. Enable controller in edit operation and disable controller in edit operation. Same deal as before. It will refresh the screen. It will add something to the undo redo stack in addition to the low-level geodatabase stuff that goes on. New in the more recent versions, we have a update all subnetworks, so you can update everything in one call to the service. Once you get individual subnetworks to that query thing, you can update them individually as well. Now, another thing that was added since we talked last year, we now have a routine that will let you redraw the map view. So you call mapView.redraw true, and what that will do is that will refresh the whole screen. When you're editing subnetworks, you're going to be changing labels and annotation and the subnet line feature. It's a pretty extensive operation, so we recommend just redrawing your whole screen. That true there will refresh the feature cache. Also from the subnetwork, you can get the subnet line feature, and you can get any network diagrams that you have associated with that subnetwork. Tracing. Everybody here knows what tracing is, right? It's a way to, in most cases, it's the whole end reason you're making this network in the first place, right? You want to answer questions and solve problems based on network connectivity, based on the current state of the network. Lots of different components that go into a trace. So there's different kinds of traces are implemented by these things called tracer objects. Then we have a trace argument that encapsulates all the input parameters into that trace, and then we get back a set of result objects. We're going to go through and cover each of these in more detail. So the tracers define the tracing algorithm to be used. You create a tracer object from a thing called the trace manager. This is kind of a common pattern. You ask the utility network object for a trace manager, and then that gives you a grouping of all of the tracing routines, kind of like Subnetwork Manager grouped all the subnetwork routines. So we have different tracer objects for each of the base traces that are in the system. So there's a connected tracer, there's a upstream tracer, a shortest path tracer, and so forth. Now the trace argument takes all of the input parameters, that's starting points, the barriers, what result types you want to see in your result, and then finally a trace configuration. We're going to talk about trace configuration for a while because this is obviously a very, very complex thing. So on the right-hand side of these slides, you'll see the equivalent functionality in the tracing geoprocessing tool. So some basic properties, including containers, including content, including structures, and so forth. This is if you want to do things like, I want to run a circuit trace and return a list of all of the poles on my electrical circuit. And those will all be scheduled for maintenance or inspection or what have you. So in that case, you just check include structures, that Boolean, set that to true, and it will return the poles. Domain network, source tier, and target tier. Now, in the user interface, you need to specify the domain network and the starting tier, the source tier. We're a little bit more flexible in the SDK. You don't usually need to specify the source tier. We figure it out based on where you've clicked, or where your starting points are, I should say. Traversability is the first thing that you have to consider with a trace. So traversability is based on either barriers or function barriers. So these are the properties that will stop the trace. So for example, you can compare a network attribute. You can check for the existence of a category, and using and or you can combine lots of different criteria. So, to use a gas example, you probably want to stop when you hit a closed valve, right? So you would set up a condition barrier, operational device status, and clearly I have an electric example on the board, but if this was gas, the value would be closed and not open. You can also stop a traversal based on a function barrier. So what this will actually do is, as you're doing the trace, it will evaluate a functional expression. So a good example here is I want to do an electric trace, and I want to go 1,000 meters down the line in either direction. So using this function barrier thing, you can set it up so that it will stop after 1,000 meters. Also with tracing, you can perform analytics while you're doing your trace. So you can specify a collection of functions to execute while doing the trace. So to give you an example here, this code is showing a function that as it's doing the trace, it is adding up all of the transformer load values where the phase includes A. You can also, you could figure out the KVA, you could figure out the number of customers on, downstream from a given point and things like that. Filters. Filters are interesting. They are a mechanism to stop tracing while you're returning results. So the important thing here is they don't stop traversability to the controller. So here's our classic example. You're doing a upstream protective device trace on an electric network from a service point. So you want to trace upstream, and you want to stop when you hit a fuse or a recloser or something that protects the current to that location. So the first thing everybody tries is they set a traversability filter, and they say, I want to stop when I hit something that has the protective device category. And then they hit run, or they execute their code in the SDK, and the trace returns an error. And the error is cannot find source. So when you're doing a circuit trace, a subnetwork trace such as an upstream or downstream, the first thing we do is we go out in every direction and try to figure out where the sources are. And if you're stopping using a traversal filter, if you're stopping when you hit a device like that, you won't go past to find your source. So what the filter does is allows you to find the source in the first thing, and then when you're returning results, it will stop at the protective device. Lots of different ways to define filters. You can use a condition based on network attributes or categories. I just showed you before the stopping at a protected device. You can also stop using a functional expression or a nearest neighbor filter or a Bitset filter. Now I want to talk a little bit about Bitset filters because that's sort of one of those things that is buried down in the documentation. You may not understand how it works. So there are cases, typically with electrical networks, when the system needs to be aware that a network attribute is a bit set that controls traversability. So the canonical example here is phase, right? So if you have a power line, we have a little phase domain, and there's different values. So the first bit is A, the second bit is B, the third bit is C. You notice they didn't tell you if it was high or low sides because I forgot. So consider this network. You have a three-phase line coming down from your controller. It hits a junction, and then it hits a three-phase device, which is, of course, made of three individual devices that are phase A, B, and C, and then those join together and continue down the line. So what would happen if you put a starting point on that B-phase device and do an upstream trace? How many paths do you think there are between that device and the circuit source? Any guesses? You want it to be one, right? Because in the real world, there's only one power line here that goes up to the source. But in the network, there's actually three. Because you can go downstream and then upstream the C line, and likewise downstream and upstream up the A line. Of course, that wouldn't happen in the real world. So you set this bitset filter on phase, and then we're smart enough to know that when you put that starting point on B, we're only going to go on B when we get our results back. It's especially great when you do a downstream trace from this and you actually get back nothing except the starting point, because everything is upstream. All right, output. The final step of the tracing process. This takes place after traversability, after filtering, after function calculation. This just restricts the features that are returned. So if you're doing a trace and you're trying to find all of the customers served by a gas line, you don't really care about the gas pipes or the services or the valves between you and the starting point. You just want to return the customers themselves. So you can set up an output filter to take care of this. And that is based on either conditions or an asset type, or a set of asset types, I should say. Propagators are fun, and it's hard to talk about propagators without 20 minutes and a whiteboard, but I'll do my best. A propagator defines the traversal, defines the propagation of a network attribute along a traversal and provides a filter to stop traversal. They only work with subnetwork-based traces, and traditionally we use them for things like phase propagation. So, you know what, I'm going to go back to this picture here. If you think about this, and you say, I want to do a downstream trace on B, and let's say this is a switch. Let's say this three-phase device is a switch, and the B device is open. So if you haven't any knowledge of electricity, you know that the trace is going to start here, and it's going to go down, and it's going to hit that thing and stop. If you don't use propagation, what we'll do is we'll say, okay, return everything downstream, that's phase B. So it'll go down to here, it'll go to here and stop, it'll go down to here, it won't return this because this isn't phase B, and it'll keep going down, and oh look, this is phase B again. So it'll actually return this line along with this. And that, of course, is not what you want. So what propagator does is it allows you to start from the starting point, and it kind of works its way down and filters what phases are available beyond a certain point. So in this example, it will come down here and it will say, okay, only A is going down here, only B is going here, B stops, only C is going down here. So the propagated values down here is just AC. Hope that made sense. If not, stop by the showcase and I'll draw pictures and do that. So basically what we have is we have a propagator class that allows you to specify these properties as you're doing a trace. Finally, we get our trace results. So when you run a trace operation, you get back a set of trace results, and that set of results depends on the set of result types that you passed into it at the beginning of your trace. So right now we have two kinds of trace results. We have element results, which just returns all of the features or parts of features that got returned, as well as function outputs. So this is a list of elements. Worth pointing out that if an edge is returned, an edge feature is returned, it returns the whole feature, which might not make sense, but it does return everything. This is what we use to build selections with the trace results. And then we have a function output result, which is a list of function value pairs. So if you calculated number of customers and sum of customer load, you'll get back two values here. Now in the future, we're going to support additional result types. So we're not sure exactly when all of these will be added. We're going to start working on it in 2.4. Some of the possible result types are going to be geometry, so you just get back one feature or a collection of, one geometry, one shape, or a collection of shapes, one for each feature. Other things we're considering are a connectivity information, an entire network diagram, maybe the propagator values for each row, maybe some additional network attributes. So when we add these to the SDK, we try to be flexible. When we design this, we're just going to add a new value to the result type enum, and we're going to add a new concrete subclass to the result virtual class. All right, so tracing. You take your tracer, figure out what algorithm you want to use, upstream, downstream, connected, and so forth. You build up your trace argument with all the different parameters, and then you get a set of result objects back. Now, we tried our best to make this framework extremely flexible. We tried to make it very domain agnostic, so we don't provide electric traces or gas traces, we just provide a trace framework. So there may be cases where you need to do a trace that this framework doesn't support. In that case, we would love to hear about it so our preference is to adjust that tracing framework rather than providing some way to make you go through and step through each edge and each junction like we did in the geometric network. Okay. Network diagrams allows the developer to query and edit network diagrams. Guess what? There's a diagram manager class, and you get that from the UtilityNetwork Class. This allows you to create and open network diagrams and templates. Network diagram itself represents a diagram generated from a portion of the network. So lots of different routines here. Some of the key ones are update and append. So what that will do is it will update the diagram. Append lets you add additional features to the diagram. You can overwrite it. You can store it, which stores it in the geodatabase. You can delete it. And slightly different now is you can apply different layouts. So this is a new function that's been added. So all those different layout options you see on the toolbar, you can now apply them via the SDK. So I won't go through all the diagram stuff. It's a fairly complex API. I will say, however, that at its core, a network diagram consists of a set of diagram elements. And those are either junctions, edges, or containers. And one of the most important properties on here is the shape property. I guess the other important property are, from ID and to ID for a diagram edge. So what the shape lets you do is it lets you change the layout and build your own layouts. So the first step of that is retrieving a set of diagram elements. So given a network diagram, you can get all the elements of a particular type. So give me all the edges. You can also do it by an extent, or here's a set of object IDs. Give me all the diagram elements that correspond to those. So once you get your set of diagram elements, then you modify the shape of each one, apply whatever algorithm you want to make it look the way you want it to. You create what's called a network diagram subset object, and then you pass that in to save layout. So that's the real high-level overview of how to create a custom layout. I believe you're going to show me some more.
Yes, I am. All right, so that was a lot of information to absorb, so take a second and just absorb it as I try to catch my breath. So I'm looking here at again, my utility network. Now I've zoomed into a specific area. I'm going to show you a quick little demo on how we can manipulate and manage network diagrams using the SDK. Again, I've had my add-ins here, and I've written some buttons that I can click into so that I can do some work. So let's pretend that in my world I have a bunch of users who run traces around my network, and every trace that they run, they create a diagram for. And they use a very convenient naming scheme of geoposition diagram and the number of the one that they've generated that day. What that's going to give them is that, so they generate those diagrams, and I've already generated one for this little area I was looking at. And it literally just puts the features in the geoposition that they are in on the map. But let's say that I wanted to write an automated process that goes and applies a smart tree algorithm to all of those diagrams. I just want to iterate through all of them, and I want to update them. That way my users don't have to do it, but I can maybe manipulate some certain types of features to be in different kinds of locations, different ways. So how would I do that? So the first way is I obviously have my diagram already that I want to update. So I can come back in here. And again, I have to do everything in my queued task.run. That is a crucial moment to realize, or crucial thing to take away from this session, if nothing else. And I open my utility network. Again, using that same method where I grab the definition, I open the network, return it back to myself. And then from that network, I go and I get my diagram manager class. So this is the object that allows me to do any work that I have to do with diagrams. From here, I can get diagram templates. I happen to open one here that I don't actually use in this demo, but you can grab any kind of template you want, apply it to the algorithm, maybe take the features that are in the current diagram, apply a different template to it, and store it elsewhere. But I just want to go and grab all my diagrams within my utility network. I then want to go and find a specific diagram that I was looking at. Obviously, in that example I gave, I would just iterate through all of them that met some naming convention and apply an algorithm to it. For the sake of a demo, it's easier if I just grab the one that I know that I want to update. So I go and get that geoposition diagram too. So now I have my diagram object. I can now apply that layout algorithm of the smart tree by creating a diagram layout parameters object set as an instance of a smart tree layout. I can then apply that layout to this diagram, and then that will actually apply it, but I also want to store it as a new name so that it matches some other schema that I have, because people are going to be going every day creating these geopositional diagrams with the numbering. I don't want to start messing with the things they've already created, so instead I store it out here as it's called Smart Tree Diagram DS for Dev Summit. Very obvious. So now you notice that nothing really happened in my display. But if I actually go in here and I refresh all of my diagrams, I now have that smart tree diagram. If I open it up, you'll see that I have that same set of features, but now they are a smart tree layout. Now, in this particular case, I don't like the way it laid out. It put this feature as the root node, which is element ID 9, but it's a service point. I don't really like that thing being there. I want this transformer, for whatever reason, to be my root node. And all I'm really trying to show you is the type of manipulations you can make with the code behind. Of course, that doesn't want to click, so maybe I'll use this one. Anyone that will click for me would be nice. So anyone who just noticed I ran into a caching issue there, but that's okay. So we'll just proceed on through. So then this transformer is actually element 8, I believe. We're going to get in there and find out, aren't we? So now I go back into that method because I want to do the update. Again, I open my utility network, same way I always do. And then I return it back. I go get that diagram manager, find the diagram that I just created. I need to update that to 8. And luckily, I am actually debugging, so I can do that. I grab my diagram layout, and again, I apply the smart tree again, just for redundancy, I suppose. And you don't actually have to apply it again. You can just add the root, add the flag and call apply layout. So I add that root flag, I apply the layout, and then if it cooperates with me. We shall see. Maybe I'll just close it and reopen it. We'll see if that helps me. But it will update it so that the root node is moved, and now it displays coming off of a different feature. So at first, that service point you saw was out here as the root node. I've now moved it down to one of the transformers as being the root node. Obviously, a pretty simplistic example, but because you have access within here, and if maybe my selection works this time, you actually have access to all of the attributes from the underlying features themselves, as well as the diagram-specific attributes down at the bottom. So within that code behind, you could go and find maybe all of the fuses in my diagram, put them all on the top, move all my breakers or something to the bottom or the left, and you could start to build your own sort of white space management and diagram, however is appropriate for your specific organization and your use cases. Back to you.
Thanks, Dave. Finally, let's talk about how to integrate the utility network in with Pro. First thing, we already mentioned this real quick. Thank you.
Oh.
We have the utility network layer class. This represents a layer in the map. You've already saw that through one of Dave's examples. This inherits from composite layer. So if you have a utility network layer, you can then iterate through and get to the dirty area and the error sublayers. As we've already talked about, there's a get utility network property on there too, method on there too. Now, if you have any existing code, please pay attention, because we made a mistake. So in older versions before 2.3 of Pro, we had this condition called Esri _mapping _ utility network layer selected condition. So for those who aren't familiar with conditions, using the DML, you assign these conditions to tools and buttons, and that controls when that object is enabled. So in the past, we had that condition, and that condition would be enabled whenever you whenever you selected a utility network layer or a layer that represents a feature class that belongs to a utility network. So we changed that, and we didn't really quite do this the right way. So we changed it by removing that condition. So with 2.3, that condition is always going to return true, and your button is always going to be enabled. So if your on button click code assumed that you had one of those two kinds of layers selected, you're not going to be happy, right? Bad things could happen. So go back to your code. We've added a new condition called Esri mapping utility network condition, and this is enabled every time there's a utility network in your map. So our users complain that they would have a map open and you'd be clicked on the background layer or a table or something, and you wouldn't see the utility network ribbon and everybody would be confused. So now that utility network ribbon is always there as long as you have a utility network in your map. So we recommend you change all your code to use this. Editor integration. If you look through our APIs, you'll see lots of methods that let you directly edit. However, if you're writing an add-in, we almost always suggest you use the high-level edit operation class. So the edit operation class takes care of all the screen redraws and cache refreshes. It creates undo, redo objects on the stack and so forth. There are methods on the edit operation class for things like create, delete, move, etc. What you do with an edit operation is you create it, you add a bunch of edits, and then you call execute, and all those edits are executed at once with one call to the service. So we've added stuff to edit operation to do utility network editing. There's a set of association description classes that you use to create or delete associations. So to give an example of a containment association description, you create one of those objects, you say this is the container, and you pass in an element, and you say this is the content, and you pass in another element, and then you call new, or you call create, and you pass in your containment association description, and that will go ahead and create the container association. So what about when you want to create two features and you want to create an association between them? And you want to do that in one edit operation. So what you do there is you call create, and on the first one, you call create EX. And that returns what's called a row token. And then you call create EX on your other object, and you get back a second row token. And then you use that row token to create your association. So this is for like if you want to create a poll and a transformer bank, and you want to do that in one edit operation. You call create EX on the second object, and then you create the association between them. And the reason why this is necessary is because, as I said, you queue up all these edits, and none of those edits take place until you call execute. So you don't have an object ID for those two features until after execute is called. So this allows us to get by that and still keep it all in one edit operation. There's a sample online showing that, by the way. So there are, as I said earlier, there are low-level geodatabase objects for editing. If you are writing a core host app, this is what you use. A core host, for those who aren't familiar, is just a headless app that runs from the command line or with a different user interface. For an ArcGIS Pro add-in, we almost never want to use these things. The only exception I can think of is if you're writing an edit operation callback, you might make some additional low-level edits using this. The editing talks are a good way to learn more, but you don't even have to wait because Dave's going to show us.
And I will. So, as Rich described, there's a couple ways to interact here with Pro. So I'm going to show you 3 different ways to get the same editing done using different ways in the SDK. So the first way, so what I'm trying to create here is a fuse bank that contains 3 fuses with only 1 click. That is my ultimate goal here. So I've hijacked a sketch tool. That's why these things are red and not blue. And the first one I'm going to show is using those edit operations integrated directly with the editor. So I can click my sketch tool, click where I want it to build it, and step right into my code. Again, I'm doing it inside that queued task.run because I'm working inside of the geodatabase. You'll see my cursor jumps all over the place because I am allowing my queued task.run to actually work. So now I'm inside of my queue task. So I'm going to create my new edit operation, give it a name, and then I'm going to start building up all of the objects that I want to create as I go. So I build up a map point where I want the fuse bank to live. I set some attributes on it, which are in this case just the asset type. I want to set it to a specific kind, a 2. And then I create my row token. And the row token is the thing that tells the editor that this is going to create a feature but it allows you to use the token later in the code to do other work. And you'll see where that comes in when I actually create some of these containment associations. So now I can do that same work for my fuses. So I create all 3 of my fuses. I then set each of their attributes, setting the phases to A, B, and C, 1 for each one of them. And each one of those, then I'm now going to create their row tokens. Using the same thing, I give it the layer that it's getting created in, the geometry where we want it to go, and the set of attributes that will be applied. I then, from those row tokens, can create row handles, which is what allows me to turn around and create these containment association descriptions. There's also connectivity association descriptions, structural attachment association descriptions, because we like being verbose. So within here, all I pass in is those 2 row handles. So I'm saying this fuse bank is going to contain this fuse row, and there's 3 of them back to back to back. And I'm going to make it visible content so that you can all see it when it's finished. Otherwise, the demo really does not work very well. I can then call the create. So I'm going to create from that edit operation those 3 containment associations. One thing I didn't point out here is that I'm actually in the edit operation itself. I'm using this create EX. That's what returns back the row token so that I can use it later on within the same edit operation. It's just a signal to the editor that something like that is going to be happening.
So just everyone knows nothing has happened now in terms of the service. No calls have gone across the wire.
Yeah. And then once I hit that execute async, that's when that whole package is bundled up and sent once across the server to the apply edits call. That way you're not eating the chattiness of, oh, create this row, create that row, create that row. That would be very inefficient ways to program, especially against a server. And I can zoom in here and you can see that I actually created my fuse bank, and it does actually contain all 3 of those fuses that were created. So that's sort of let's call it the verbose way to create things using an editor operation. Now, I also enjoy templates. So I have created a preset template that will create all of those things. Now, right now, templates are only available through Pro. They're saved with the project. Eventually, if they go across the platform, you can see how this could be expanded over time to be used. But in here, it's a fun little demo because it shows with very little code. So to create all those features, that was the 100 lines of code or whatever it was, I can do the same exact thing by simply getting that preset template that I want to use. Let's make sure I actually got it, because I named it something very long to make my demo more fault tolerant. And then I can call create to just create the template. So it's actually going to create the entire template for me at the location that I tell it to. And it's going to use all the configuration within that preset template to know what to put down and where. So again, there's like 2 lines of code, and I'm able to create that same set of containment and features. And the last way is using that core data. Again, this is if you're writing sort of a core host headless application. It's not ideal to use it within an add-in, but for the sake of showing you what the SDK can actually do, it helps. So in here, we again create our map points for where our fuse bank are going to live, create the points where all of those fuses are going to live, offset them all a little bit. And then because it's core host, I've got to actually go open the utility network. I've got to open all the network sources that I need to use, find the asset group, asset type I want to create my features in, make sure that I didn't make a typo, open the actual classes because I'm going into through the core data itself. I have to go to the raw class and say edit it. I can't go to a layer. I then am going to find my subtypes because I got to make sure I'm creating the feature in the correct subtype. That's when we create these row buffers. They go in with a subtype parameter. That's how you get a row that comes out of the correct type immediately without you then having to grab an empty row and set the subtype on it. We can set our asset type, set our phases for all of our fuses, create all of our row buffers, and then within our first apply edits call, we can create all the rows. From that, create elements out of the utility network so that I can then turn around and add all of the containment. And I realized I put this within my qtask.run, which means it doesn't actually refresh the map. So that's a helpful what not to do with your code. Put it outside the qtask, and then then it clears the cache, and you don't have to deal with what I just did there. But you can see if I get control, I can click that fuse bank, and I again have created that same level of containment. So it's 3 different ways to get to the same endpoint depending on how exactly you want to do it. Do you want to be fully integrated in Pro, use templates, or use core host applications?
Okay, thanks. So what's new in the last year? Quite a bit of things. So last time I talked about how we didn't integrate well with Pro. Now that we've added those extension methods for validate, topology, enable, and disable controller, we're much better off. Didn't talk about it today. We don't really have time to go through every method, but we have a new thing called get association features. And this allows you to get back those graphics that you get when you click the show associations button on the ribbon. So it makes one call to the service and gets back a bunch of graphics. We've added the ability to apply layouts to network diagrams. You can also now export network diagrams to JSON if you want to move it into another kind of package. You can update all subnetworks in a single call before you had to go through and iterate through, which made multiple calls to the service. Also filled in some missing schema information. We now have information available about tier groups, terminal configuration paths, some of the other network attribute properties, and then things like last update is connected and container split policies. And again, that new DML condition, that's probably the one thing you should go out and change in your code now. So in other areas of the SDK, things that might be important, we added a object IDs property to query filter. So it just takes a set of object IDs. In the past, what you had to do is you had to create a where clause with an in clause. And some database types will choke if you have too many object IDs in that in clause. So you had to break it up into multiple queries. That's all taken care of for you now. The reason I bring it up in this talk is you might just get back a set of object IDs from a trace, and you need to actually fetch the features associated with them. If you're using the utility network, you're using branch versioning. The table.differences routine will now allow you to get back version changes between your version and default. It's good to know. And we also have the ability to execute attribute rules. We'll talk more about attribute rules in another session later today. So things in the road ahead, some of the things we know we need to do. We are missing just a little bit. Thankfully, the missing functionality list is a lot shorter than last year. We need to add support to the SDK for the isolation trace, and there's one property on Propagators called Substitution Network Attribute that isn't there yet. The plan is to add both of those for 2.4. We will also be adding support for future functionality as it is developed. So we know the big things that we're working on this year is support for telecom, in particular making changes to the internal model to allow non-spatial edges and junctions. So we'll add access to that via the SDK as well. And we're also looking at adding new result types to trace, and those will be added to the SDK again as we can. All right, so I think we are almost out of time. Real quick, if you go to that Pro site, you can get a link. You click on this utility network thing, read the topic. There's pages and pages. Everything that was in this talk, plus a lot more. There's also a link to samples. We have a number of samples up there today. Category usage, which demonstrates how to use the schema. A load report sample, which demonstrates how to use tracing. And some editing examples to place a transformer bank. If you want to see additional samples, let us know. We will add it. Also worth pointing out that it's a GitHub site. It's a community site. We do welcome submissions from the user community. We also have a set of snippets. These are just small pieces of code that you can copy and paste in. Shows you how to accomplish a specific task. A full API reference, of course. And exclusive to the utility network, no one else in Pro does this, but we also have, click on this, you can get an object model diagram. Old school, warm up the plotter.
2 years running, it's the only thing that gets an applause.
It is the only thing that gets applause. So I know that going through this, how to get more information, most people, one developer told me, can't you just use Google? My answer to that is, but you don't know what you can Google for. Now you know. So a couple more sessions coming up later this week about the .NET SDK. In particular, I'll be going through the Geodatabase API at 1 o'clock today, and we also have a road ahead session later this afternoon. So with that, I think we probably have a few minutes for questions. If not, you can just come up afterwards and ask them. Anyone want to ask in front of the group? All right, we'll come up afterwards or the showcase. Yes?
So for the telecom piece, have y'all got any published data model for that yet?
We do not have a published data model for telecom. We're still working on the information model and figuring out how we think things like patch panels and stuff are best represented in the UN. Thank you.